Laid down in October 1980, Seabex One was launched on the 1st of July 1981. She is completing her final tests in Statfjord Bay before leaving for work on her first contract. The four powerful firefighting cannons project up to 7,200 cubic meters of water per hour and are controlled from the bridge. They offer the possibility of efficient firefighting operations both on board the vessel and for an offshore structure. The diving equipment, which is an integral part of the vessel, is designed to accommodate 16 divers in saturation to a depth of 450 meters. The diving bell is launched into the very large working moon pool, 8 by 14 meters. Powered by 6 thrusters, Seabex One is extremely maneuverable and can position itself and maintain station without any assistance. The helicopter deck is situated on the forward part of the vessel. The motion-compensated crane has a lifting capacity of 50 tons at 14 meters outreach and 100 tons over the moon pool. Overall length of the Seabex is 104 meters. Here we see Seabex at sea en route for the Statfjord oil field where a hyperbaric welded riser connection is to be performed. The cruising speed of the Seabex is 12 knots. The vessel is designed to accommodate 96 crew members and subsea operations personnel and 500 people in the case of a rescue operation. The Statfjord platform is in sight. The ship is to be positioned very close to the platform and with great precision. The main console brings together all the vessel's command systems. A computer is permanently interrogated and the different parameters appear on a screen. The dynamic positioning system maintains the ship vertically over the work site and can do so in sea conditions up to Beaufort force 10. During the course of this first work site, the dynamic positioning system was found to be absolutely reliable. This is evidently a major security factor for such a vessel, which is permanently supporting diving personnel on the seabed. Operations immediately get underway. The job consists of a welded hyperbaric connection on a 36-inch pipe at the foot of the platform. The hydraulic H-frames are lowered to the seabed by the Seabex crane. Maneuvering is rapid and precise. The submarine welding habitat, weighing approximately 44 metric tons, is immersed in its turn and positioned on the pipeline. There are over 1,000 square meters of unobstructed deck space on the main deck of the Seabex. The pipe fitters and welders will soon be in action and rejoin the divers in saturation. Once the preparatory work is finished, the miss is lowered to the bottom. This module, which regroups all of the functions required by the welding habitat, will be connected to it via a perfectly watertight seal. All subsea operations are observed directly by a small submarine robot, the RCV, piloted by an operator on the vessel. The pictures from the seabed are shown on screens installed in the operations center. Here we can see connection of the MISS module to the welding habitat. In the ultra-modern dive control center, the technicians monitor all of the parameters of the saturated diver's environment 24 hours per day. The diving saturation system comprises 7 chambers which allow use of 3 separate living depths. Meals are transferred via a small lock. By means of a television camera network, the divers in the chambers are surveyed permanently. Marine and submarine operations are, of course, affected by the weather. In the North Sea, these weather conditions are always difficult and can deteriorate significantly in a few hours. Seabex is to leave the platform rapidly. Only the miss is recovered on deck. The storm, of rare intensity, will last for 3 days, during which time Seabex stands up to the elements very satisfactorily. The stability of the sequences filmed on board bear witness to the vessel's performance. Storms are, of course, frequent in the North Sea, and working vessels must therefore be able to weather the elements without having to seek calm waters in a port. The welder-diver team is kept in saturation, ready for operations as soon as the weather allows it. conditions are fine again, and Seabex will rapidly take up her place next to the platform. The bell is lowered, taking with it the first team of welder pipe fitters. Each operator is at his post. The bell is clamped onto the welding habitat. On this drawing, which represents the subsea work site and its geographical situation, we can examine the position of the different modules, the two H-frames, then the welding habitat on which the miss and the diving bell are positioned. The welders have started the transfer procedures to the welding habitat. As soon as they arrive in the submarine welding habitat, after closing the door, the welders prepare the miss, which is the heart of the system. The miss comprises, among other things, the vital functions of regeneration of the ambient atmosphere and communications with the surface. The moon pool of the Seabex is maintained vertically over the welding habitat during the whole length of the operations. Pipe fitting is a specialty requiring great precision. The possibility of a simple cutting mistake is not allowed, as it would result in a loss of several working days. A hydraulic cutting machine is placed on its guide and adjusted. All operations are followed by the engineers on the surface, who speak directly to the team on the bottom. After penetration by the cutting machine, the advance of the machine is automatically regulated. The excess length is removed. Naturally, the tool simultaneously machines the chamfer. Final pipe alignment is undertaken from the interior of the habitat by means of a console which controls the movements of the hydraulic pipe clamps, which are situated on the outside of the habitat. The cut is verified by means of a gauge and lightly touched up by a grinder. The spool piece, prefabricated on the surface, cannot be modified. This explains the importance of a precise cut. The spool piece is positioned and held in place by special clamps. Spacing between the chamfers is adjusted according to required specifications. The preheating mats are installed and fixed onto the pipe. Each welder has an extraction unit to remove welding fumes, the extremity of which has a magnet which maintains it in the desired place. Numerous accessories are connected to the MIS, electrode oven, grinders, etc. All these accessories are placed in small, waterproof containers. Now the only remaining operation is welding.
Might I say you look awfully familiar, volunteer from the audience?
The finished weld will undergo X-ray and gamma-graphic inspection. After this final control, an anti-corrosion coating is put on the pipeline. Seabex has been maintaining station over the worksite since the very beginning of operations. The RCV, an invaluable asset for work observation and control, is recovered to surface. The diving bell returns the last welding team to the chamber. The divers will then go into action to bring up the subsea equipment, the welding habitat, and the H-frames. Diver assistance is not necessary to bring up the MIS, which is installed on its support frame. Work on this work site is now finished. The loading tower is joined to the platform. Seabex One, a complete success.